Good evening, everyone. Today, our group will be presenting about Stack, and that is Browser and Application Manager. Next. So this is our team, Haziq, Haizal, me, myself, Irfan Firdaus, and Ami. Next. So here is the overview of table of content. We have introduction, operation, demonstration, algorithm, performance, conclusion, identification, and summary. Next. Introduction. So the application name is Browser Navigation Manager. So in the description, it says that the system designed to replicate the functionality of the browser system. So this application uses Stack data structure to manage navigation history efficiently. Next. Next. Operation.
For the operation, we use 5 main operation, which is the visit URL. When visiting a URL, the current URL is pushed to the backward stack and clear the forward stack. And the second operation is backward operation. The third one is forward. The fourth one is display current URL, and the last one is clear forward history. Next. The data organization and storage pattern, we use stack because the LIFO behavior and the two separate histories and efficient operation. Next. Okay, this is the first stack operation, which is the push operation. The push operation is used when we are visiting a new page, when we are pressing backward button and when we are pressing the forward button. Next. And the second stack operation, which is the pop operation, is used when we press the backward button and when we press the forward button. The last stack operation is the clear operation. It is used when we are visiting the new page. Next. Okay, this is the summarize of the stack operation. We got push, pop, and clear. Next. Next, this is the demonstration video that we have provided. Okay, I will pass it to Muhammad Irfan for the algorithm part.
Right, so here is the backward navigation algorithm. So as you can see, we have 3 inputs, that is current state URL, backward stack, and forward stack. And as for the output, we have current state URL after navigating backward and modified backward stack and forward stack. Next. So here are the 3 main points to check if backward navigation is possible. That is using backward stack. If it's empty, it display not available and return to the no action taken. So we have performed backward navigation, that is using current state URL onto the forward stack, and then pop if the page from the backward stack and set the pop page as a new current state URL. And end of operation, we just print out the return update using current state URL. Next. So here is the pseudocode for backward navigation. We have current state URL, backward stack, and forward stack. If backward stack is empty, then we print now not available and return. And we push the current state URL into the forward stack. Current state URL pop from backward stack and print navigate backward. Next. So here is the breakdown of how the method in Java code works. If backward stack is empty, we just print out not available using system out printing, and then we push forward if you want the current state URL onto the forward stack using forward stack.add. So to pop the URL using the backward stack and set it out as the current URL, we use current state URL equal to backward stack.pop. And to update the current URL, we just print out navigate backward current URL plus current state URL. Next. performance.
So for the performance, so for the algorithm steps, check if the backward stack is empty. So the time complexity, which is constant time and is empty, checks whether the stack contains any elements. And then push current state URL onto the forward stack. Add function appends the current URL to the top of the forward stack. So for the time complexity, also constant time. Then pop the top element from the backward stack. Pop function removes the top element of the backward stack and returns it. So it also constant in time complexity. And then the update the current state URL. Assign the pop value to the variable current state URL. It's also constant time. And then print the current URL. So this involves strings and sending output to the console. So next. So for the overall time complexity, the dominant operations in the algorithm are stack operations, which is push, pop, and is empty, all of which have a time complexity of constant. So final time complexity, the algorithm is highly efficient, operating in constant time. Next. Next. So for the space complexity, the algorithm uses two stack, which is backward stack and forward stack, to store URLs and one string available, one string variable, which is current state URL for the current page. So total space use, space complexity, where K is the total number of URLs stored in the stack. Next. For the efficiency estimate, fast and scalable, the constant complexity ensures that the algorithm is highly efficient even with large numbers of URLs in the navigation history. Space complexity grows linearly with the number of visited pages. For the key observation, since navigation operations, which is push and pop, are constant time, the algorithm is highly optimized for real-time applications such as browsers. So this is the steps to final answer. First, we have to analyze each operation in the algorithm. Second, we have to determine the complexity of individual operations. And last, we have to combine these complexities. The dominant operation, which is push, pop, and is empty, all have constant complexity. That's all. Yes.
Next is identification. So this is the code for browser navigation app that we have found. First, they declare a stack named forward stack and backward stack. Then for the forward method, if the current stack is empty, the system will display not available. For the backward method, if the current stack is empty, the system also display not available. Then they declare a simulator function method. So then this is the output of the code. First, the current URL is aj.com. Then current URL is abc.com. After that, pressing a backward button, it goes back to aj.com. Then pressing a forward button, the current URL is abc.com. After that, input a new current URL named nikhil.com. After that, after pressing a forward button, the system will display not available, and the current URL stay in nikhil.com. And then after pressing a backward button, the current URL is abc.com. Then the collection class and interface use. First, collection class is stack. Stack is the main class used in the code. It is part of the Java util package and represents last in, first out. Then for the interface use, first is this. The stack class extends the vector class, which implements the list interface. The list interface provides all the collection with access to elements by index. Then second interface is collection interface. Collection is the root interface for the collection framework in Java. It provides common method for all type of collections like set, list. Then for operation, for collection class, which is stack, there are 4 operation. First is add, then pick, pop, and is empty. For operation interface, which is collection interface only, we have 2 operation, which is add and is empty. Then the summary. For the conclusion and summary, the use of Java stack class proved to be an effective choice for this application because of its simplicity, efficiency, and direct mapping to the requirements of a browser navigation system. The backward stack and forward stack work in tandem to handle the user navigation history, enabling smooth transition between pages. To sum up, the project successfully demonstrates the implementation of browser navigation functionality, which is backward and forward buttons, using the stack data structure in Java by leveraging the default, which is last in first out nature of stacks. The application efficiently tracks the browsing history and ensures smooth navigation between web pages. So this is for reference pages, this is the link to coding application. So that's all from us. Thank you.